In this video, we are going to solve some problems based on thermal energy. Water is heated in a pan on a stove top as shown in the figure below. Which process of heat transfer is involved in heat reaching the hand through the metal handle at A? So we can see that in the diagram there are three labeled positions or three labeled parts of the diagram A, B and C. A is shown at the metal handle, B is shown for the fluid or the liquid which is there in the vessel or in the pan, and C is for the heat which is coming out from the stove top. So for the A, which is in the metal handle, we know that it is convection because convection happens in solid. The question is just asking for A, but we can also think about B and C. B is convection because it's happening in the liquid. Convection happens in liquid. C is radiation. It's the heat radiation given out by the hot coil, and we know that radiation can travel without medium, though here it is with medium. Obviously there will be air around it, but because it's heat radiation, so the process which is happening, heat energy is being transferred from the coil with the help of radiation. How much heat is required to raise the temperature of 250 gram lead ball from 10 degrees Celsius to 25 degrees Celsius? The specific heat of lead is 128 joule per kg Kelvin. So the mass is given 250 gram, which will convert to kgs, and the temperatures are given to us, initial and final. We can write that. It's asking us to find its specific capacity is also given to us, which is 128. It's asking how much heat, that means Q is being asked. We can use the formula MC delta T. All the numbers are given to us. Delta T means change in temperature. That means we have to do TF minus TI, which is 25 minus 10. And then we can calculate it to get the answer as 480 joules. Next problem, in the process, 850 joule of heat is added to a system and 500 joule of work is done by the system on its surrounding. What is the change in internal energy of the system? So the question is talking about heat, work and internal energy. That means we have to apply first law of thermodynamics, which is delta U equal Q minus W, where Q is the heat and W is the work done by the system. So 850 joule of heat is added, so we can write Q as 850. Because it says added, we'll put it as plus 850. Then the work done is 500 joules, and it says work done by the system. So in our formula, because W is the work done by the system, we'll put it as positive. Now we have to find what's the change in internal energy, that means delta U. So we have got all the numbers, we can just substitute and we get the answer as 350 joules. So change in internal energy is 350 joules. A student melts a 0.5 kg block of ice at 0 degrees Celsius. So the mass is given as 0.5 kg, and it also says that the ice is at 0 degrees Celsius. Calculate the energy required to melt the block of ice. Melt means to change the state. And for changing state, we know that the formula is, let me go step by step. The formula is MLF, where M is the mass and L is the latent heat of fusion. The mass is given to us. Latent heat of fusion will be given in the formula sheet with the constants. As you can see on the right hand side, I have put the constants there. So latent heat of fusion of water is given as 3.35 times 10 to the power 5. We'll put that number. We get the answer as 167500 joules. Another student boils 0.5 kg of water at 100 degrees Celsius. So boils. Boils means it should be change in state. It is change in state. And the formula will be Q equal MLV. So the mass is given to us 0.5 and the latent heat of fusion, latent heat of vaporization is given to us, which I have labeled in the constants. You can see here, which is 2.26 times 10 to the power 6. We substitute that number and we get the answer for Q. So what we need to remember here is to choose the formula correctly, because it's saying change in state. The word used is melting, boiling, and it's melting at 0 degrees Celsius, boiling at 100 degrees Celsius. That means we have to use the formula Q equal ml and not Q equal mc delta T. That's what we have to remember, choosing the formula correctly. Secondly, the constants LF and LV, they are given in the constants list. So you should check in the formula sheet to get the numbers for the constants. Next is asking the energy required to boil water is, then I fill in the blanks, the energy required to melt the same mass of ice. So we want to compare, is it greater or less or equal? Obviously we can see that the energy required to boil water is more than the energy required to melt the ice. So that means energy required to boil water, we have to write, is greater than the energy required to melt the same mass of ice. Next problem, the figure shows 3 beakers P, Q and R filled with the same liquid. That means they will have same specific heat capacity because it's the same liquid, but they are at different levels. Okay, all are at the same temperature, so their temperature is same, they are same liquids, but the only difference is the amount of liquid is different. So which beaker has the greatest thermal energy? And we know that thermal energy depends on the mass. More the mass, more the thermal energy. So beaker P has more liquid, that means it has more mass, so it will have greater thermal energy.